everybody, so we're back to some algebra story problems. This time we're going to tackle a couple different examples using the distance equals rate times time problem. So I have two situations here. One situation you might have seen before in a setup or a picture in your book where you have two people walking towards each other. They will give you the rate of the first person, I have right here 5 meters per second, the rate of the second person, which is 7 meters per second. And then they'll say something like they are 205 meters apart. So they'll give you a total distance that they are apart. And then they'll ask something like, when will they meet? When will they meet? So that's asking a time. That's a question of time, right? So we're going to use this relationship of distance equals rate times time. Now, the big thing with D equals RT problems is you have to understand the relationship of the distances. In this case, the distance of the first guy plus the distance of the second guy is going to equal 205. So their distances are going to add up to 205. So let me write that down. Distance of A plus distance of B will equal 205 if this guy is A and this guy is B. All right? So now, if you understand that the distances are going to add up to something, now you can represent their distances in terms of rate and time. So the distance of guy A is his rate times his time. Distance of guy B is his rate times his time. They're still going to equal 205. Now, one piece of information I did not give you is their time. Let's say they left at the same time. Left at the same time. Left at same time. They also have to give you that fact as well. So if they left at the same time, that means they're walking the same amount of time, correct? So their times are equal. In other words, the rate of guy A is 5. The time of guy A, we're just going to say T. That's our unknown. Plus the rate of guy B is 7. The time of guy B is the same as the time of guy A, right? So we're going to use a T for him as well. Now that equals 205. So now you have a pretty simple equation that you can solve and find T. So 12T equals 205. T is going to equal 205 over 12, whatever that is, in seconds, because we're in meters per second. So that's going to be your answer. If they ask when do they meet, the answer is after 205 over 12 seconds, whatever that decimal is, if you want to change it to a decimal, okay? So that's where the distances add up to equal one big total distance. On the flip side, another distance equals rate times time problem is where you will have two distances that will eventually be the same. The two distances are equal to each other. Here's the situation. We have a snowplow that left at 6 a.m. going down the highway, and we don't know his speed. So R equals question mark. We have a car that leaves at 8 a.m. going down the same highway, going 20 miles an hour. The car catches up to the plow 30 minutes later. Okay, so the word catches up or overtakes or passes, that is all code for the distance of the plow equals the distance of the car. Because if the plow's going here and the car catches up to him, they've gone the same distance. Okay, that's what that means. So now we have the plow distance equals the car's distance. Now we can represent their distances with their rates and times, okay? So the plow rate, we don't know, but we know that, let's think about the time for a second. The car catches up 30 minutes later. That's a half of an hour. So that's 8:30, basically. So if the plow leaves at 6, at 8:30, he's been traveling for 2.5 hours. The distance of the car is his rate times his time, which is 0.5 of an hour. We have to keep everything in terms of hours, okay? So then from there on out, It's easy to find. We want to know the rate of the plow. You can find it pretty easily there. Let me know if you have questions. There's the basic setup of 2 good examples. Thanks.